And our next presenter is Anna Beard, representing the Whitney Laboratory for Marine Bioscience.
Hello, everyone. How are you doing today? You can hear me, you can see me. We're all good? Perfect. Well, first of all, thank you so much for that introduction. And thank you so much, Dr. Dix, for your introduction to the Wet Feet Project. And I wanted to express my excitement and happiness and gratitude for working on the Wet Feet Project and for all the hard work that the team has done and picking these sites, making these warming chambers, and letting me kind of jump in the end to do some nutrient evaluations. And I'm looking forward to telling you guys about the evaluation of climate-induced changes to porewater biogeochemistry in the saltmarsh mangrove ecotone. So, as many of you well know, we have a changing saltmarsh system. We have an ecosystem that's experiencing a lot of changes. It's experiencing mangrove encroachment and is also experiencing a warming planet. And these systems, are super vital to our ecosystem and to our to our lifestyles and provide a lot of ecosystem services for us. And this leads us to some interesting questions as scientists. And as Dr. Dick stated before, the 3 sites that were studied actually represent the northern portion of the mangrove saltmarsh ecotone. And this ecotone has been experiencing mangrove abundance for at least 250 years, as Dr. Samantha Chapman had found in her recent publication. And each of these 3 sites differ in their mangrove encroachment and their duration. Of course, we have this north site here with the least, and the middle Gabby's Creek and North Matanzas have these different mangrove encroachment episodes. So sorry. And the objective for this research was to conduct this year-long seasonal study of porewater nutrients to kind of determine how Avicennia germinans expansion into the saltmarsh ecosystem that are dominated by saltmarsh vegetation is going to affect porewater nutrient dynamics and how that process can be further affected by climate change. Now, this leads me to my hypotheses. Now, there's 2 that are each kind of approaching the 2 different questions that these ecosystems are experiencing. We have this changing vegetation effect, which the black mangroves, and as many of you are well aware, but if you're not, black mangroves have nematophores, and these nematophores actually stick out of the soil and they extract oxygen from the environment and bring this down to an anaerobic soil environment. Now, this is actually causing root zone oxidation, and we hypothesized that this was going to accelerate nutrient mineralization in these saltmarsh soils through this increased root zone oxidation, and it's going to be resulting in higher nutrient concentrations than in saltmarsh vegetation. Now, we also have our second hypothesis, which is going to address this 1.6 degree rise effect that we are seeing, that we will be seeing in our near future, that these warming temperatures would actually accelerate soil nutrient mineralization processes in both these warming plots, Avicennia germinans and saltmarsh vegetation communities, resulting in these higher nutrient concentrations than in historic marsh, which we are actually focusing on more of the control plots. Now, I'm so happy that I don't have to tell you guys and spend some time talk about why nutrients matter. Nutrients matter in a lot of different aspects. I think we all know here the importance of blue carbon, the importance of how these ecosystems actually are a huge sink for carbon, and also the good sides, but also the bad sides, that nitrogen and phosphorus nutrients can lead to a lot of problems in our local systems. Now, I wanted to briefly talk about how we collected porewater. I've had a lot of people tell me that collecting porewater is almost like squeezing water from a stone. And so I wanted to kind of go over how we did this. Now, we had 25 centimeter PVC pipes, and each of these were capped on the end, and about 10 centimeters we kept above the soil, and the remainder 15 we kept below the soil. In between this 5 and 7 centimeter length here, We made some, some cuts with the bandsaw, and we actually lined this with a 0.7 micron glass fiber mesh to keep debris from entering. And then upon coming to the sites, we would actually uncap this, and all wells were purged prior to sampling. And we would use these little homemade syringes to extract the pore water out of the well. And then here's one that you can see with those black mangrove nematophores I was speaking about earlier. And you can see one here deployed. And I wanted to show a quick schematic of what my sites look like. We had 4 warming chambers, 4 blocks of warming versus non-warming of these 2 contrasting vegetations, mangrove and saltmarsh treatments. So we had our control mangroves and our control marsh, our warmed mangrove and our warming marsh. Now, getting into the good stuff. So here is my hypothesis summed up in one graph, which I really like. Big shout out to thank you to Dr. Tracy Schaefer for helping me with this one. So we have our contrasting vegetations here, marsh and mangrove. We have our control versus warming treatments. And then we have our locations here, Big Mama, Gabby's Creek, and North Matanzas. And as it turns out, as you can see from this, for maybe first glance, there was a lot of variation that we found in our sample and in our samples, and we found that there were no statistical significance between the contrasting vegetation or the warming treatments and the non-warming treatments, which in soil is good news, right? So we have our total phosphorus, our total nitrogen, ammonia, and dissolved organic carbon that we measured. And at the end of the day, you can almost tell in between these that they're almost identical between the vegetations, in between the control and warming plots. We do see a lot of variation, but at the end of the day, we found that our hypothesis was not supported. And I wanted to briefly state before I move on to the next slide that Dr. Chapman and the team, they actually did achieve that 1.6 degrees Celsius rise ambiently within these warming chambers, and that on average, the warming plots were about 2 degrees warmer than the control plots. But I wanted to bring your attention quickly to some below ground temperatures. I was looking at pore water nutrients, again, below ground, about 15 centimeters below the soil. And as you can see quickly, we have our control and warming here, and then we have our mean temperatures and 2 sites, Gabby's Creek and North Matanzas. Big Mama, the hobo, decided to be a diva, as we all know field equipment can like to do at times. But we had enough data to look at Gabby's Creek and North Matanzas to this below ground soil. And as you can tell here from these plots, again, there was no significance between the control and warming below ground either. Now, this one, maybe we can draw some parallels as to why we saw what we saw, that although we are seeing this rise 1.6 degrees or this 2 degrees Celsius rise ambiently, it might not always reflect what we're seeing below ground. Now, again, this is some good news, but switching gears, we'll go back to that later towards the conclusions. But where we did find significance was in seasonality. So in seasonality, again, we have our marsh and mangrove vegetation, our nutrients measured, and of course our sites. I want to make a quick disclaimer and just briefly say that, again, we did not find significance in the marsh and mangrove vegetation. We found it in nutrients versus season only. And as you can tell here, there's a lot of interesting things going on, especially here at Big Mama. You see a large variation in this summer of 2020 as far as nutrients goes. And so again, this is suggesting that temperature does have this effect. And maybe we're not seeing this for the way that we measured, or it's being assimilated before it's measured, before we are measuring. But again, you can see a lot of interesting things going on seasonally. And we also found significance in site. Now, we expect that. We expect a lot of variability between and among sites. But I have this PCA biplot here. And again, this axis here is explaining 59.3% of my variation, along with this second axis of 19.2% of my variability. And then we have our sites here, Gabby's Creek, North Matanzas, and Big Mama. And these ellipses are kind of showing the similarities or lack thereof. We see here excuse me, my dots are actually my individual sampling, and we have our parameters that we measured. Now we can see here that Gabby's Creek is kind of suggesting a governing of total phosphorus, and that this phosphorus is accounting for a large point of the variability among these samples. And the same thing is said to be here in the various forms of nitrogen in Big Mama and North Matanzas, and how kind of, dissolved organic carbon is being kind of neutral to all of these sites. Now, conclusions, what does this mean? The data is suggesting a resiliency in mangrove saltmarsh ecotone and is in poor water nutrients as far as temperature exposure and that changing vegetation goes. And this is an awesome sign. We walked into this not knowing what to expect, and we have this beautiful ecosystem that all of us really, really love. That's why we're here today, to hear more about it. And I'm happy to find that this is a resilience among this ecosystem and all the changing that it's experiencing. And again, we found significance in seasonality and among individual sites, suggesting that variability. And then we also have our results for total phosphorus, total nitrogen, dissolved organic carbon, and ammonia measurements. Again, showed no significance in differences between the warming and non-warming plots, and between mangrove and saltmarsh vegetation. The warming results, it could be, there's a lot of confounding variables of why we saw what we saw. But as far as the warming results, it potentially could be due to that amazing ability that soils have to insulate temperature, and how that while we may be seeing that change above ground ambiently, might not be reflected 15 centimeters below ground, where a lot of this root activity and these nutrients processes are happening. And the vegetation results, again, could be due to differential uptake and limiting nutrients by mangroves. But however, the dynamics of poor water nutrients under these conditions and communities are remain a bit unclear, which leads me to my future studies and an ultimate caveat. Ideally, this study should have continued 2 to 5 years to really better understand nutrient dynamics and really what's going on. For the sample length that we did, the 1-year seasonal study, I don't know if it's possible that we were detecting these differences that
3 minutes
that we are most impactful in just 1 year of sampling. I will say that, Dr. Todd Osborne and myself are already cooking up some ideas of how we can better this in the future. I definitely would like to look at, soil mass balance, nutrient tissue analyses on top of poor water nutrients, because again, there's so much variability. There's so much that you could suggest. You can and cannot draw parallels from just looking at, that. So with these caveats and with what we have learned from here, I wanted to say thank you quickly to everyone that's helped. I've had a lot of help sampling. This was a year-long study, and we've had a lot of adventures out there in this beautiful ecosystems. Thank you to Dr. Osborne, Dr. Tracy Schaefer, Taryn Chea. I had some amazing volunteers. I had my kids out there, putting them to work on the weekends when we were too busy to sample. And with that, I will take questions.
Great. Thank you so much, Anna. This was a wonderful supplement to the Wet Feet project. We had some questions come in during your talk. Have you investigated the effects of temperature on nitrogen fixation in the root zone?
Not as far as nitrogen fixation. No, we have not. We were basically getting a snapshot in this. This was what we were kind of considering a baseline of what we're looking at in this new venture that I'm going on in our lab specifically. So I haven't looked at fixation, but it's something that we're definitely interested in, that we want to bring into our continuation of this awesome study.
Definitely a great potential next step.
Absolutely. Mm-hmm.
Do you have any thoughts about why nutrients seem to be higher in the summer of 2020 compared to other seasons, specifically maybe at Big Mama?
Actually, I have a hypothesis, all right? I have an idea, right? Well, when I was reading Dr. Samantha Chapman's recent publication, She had spoke about this, and then a couple other scientists as well, as we were kind of putting our brains together. Big Mama has the least amount of mangroves in comparison to these three sites. This is basically a salt marsh dominated system, and the root systems of salt marsh and of course mangroves are absolutely different, and they flux and store things differently. And with the, as far as the salt marsh, I'm assuming that this mangrove root systems are actually assimilating these nutrients before we have a chance to capture it in that one snapshot that we're taking in our sampling. So I'm assuming that because of the nature of salt marsh root zones and root systems, that they're more of a concentration and more of a sink and a storage versus an assimilation that may be happening with mangroves.
Thank you. Do you know if you have any pore water sulfide or sulfate concentrations from any of your sites?
Well, we definitely know it's there, and we definitely know it interferes with nitrogen and the way it's stored and fluxed a lot, but we did not look at sulfate or sulfide. And that is, again, something else that I would love to, that is one nutrient that I wish, along with dissolved oxygen, that I wish I would have looked at in this. Kind of like the mini Captain Hindsight moments that I've had in this study, where you're like, I knew that, like I knew I was supposed to do this and I didn't, but it was one of those things. So thank you for the point. It's an awesome question, and it will definitely be something that we will be looking at in the future.
Great. Do you think it might be possible that nutrient concentrations were similar between the marsh and the mangrove sites because the nutrients are rapidly taken up by the plants, and maybe they can't accumulate in the pore water from your samples then?
Absolutely. It's an awesome observation. And yes, I think that has a lot to do with it. And that's what I wanted to really go into depth with in my conclusions and my caveats in the future studies, because I think what I've learned in this process, which has been so much, but the biggest thing I did learn is that pore water nutrients are a great snapshot of what's happening in that very second, in that moment, whereas the soil and the sediment are actually will help you better tell that story. So I think in the future, kind of adding this to the soil and sediment, again, mass balance, tissue analyses, a lot of different aspects of what we can do with our soil. And then, and also in turn, look at pore water. And then we can really see and answer that question a little more thoroughly.
Thank you. There was a comment, there seem to be big differences in the nutrient input to the soils due to the growing season of Spartina in the marshes. Do you think maybe some of the seasonality difference could also be influenced or driven by biomass turnover?
Absolutely. Yes. Again, great. And also awesome feedback for myself too. Again, this is just a huge learning experience. And I absolutely think that these growing seasons, and you can see in the winter, as far as mangroves, you had TP just blow off the chart, you're in certain times. And of course you had nitrogen, again, in certain places, just again, during the summertime, just again, accelerate a lot. So absolutely, I think seasonality growing seasons had a lot, and that biomass accumulations had a lot of influence over that seasonality difference.
There was also a comment, maybe the season when mangroves are reproductively active, maybe that could potentially be having an influence as well.
Absolutely. I think, I'm sorry. Absolutely. Again, I think these are all great points to make. And again, helping us kind of also wrap our brains around all the different factors that could be potentially due to this seasonality and the seasonality change. But I think going into the future with all this information, and of course, this amazing feedback, that this is something that we will be taking into consideration as we're moving forward. But ideally, I want to continue a study like this, maybe not the warming and non-warming, but maybe just that nutrient evaluation within these different types of vegetation for a good 2 to 5 years, just to really get a grasp on the changes that we see, and if those changes are consistent or maybe they're not. So I would love to keep you guys informed, and maybe next year this time I can bring you back with some bigger updates and some soil, and talk about soil, and we'll get into that one.
Great. Thank you, Anna.